All right, this one, example 4, evaluate the limit if it exists. Once again, if I try to put 0 in right off the bat, I can see divided by 0 is going to happen, but I want to make sure it's 0 over 0. If it's 25 over 0, it's an infinite limit, use a table. All right, so you want to do this every time, just in case if it ends up being number over 0, use a table. 0 over 0, try and work it out. So, if I put 0 in, I'm going to get the square root of 0 plus 9, which is 9, minus 3 over 0. That's 3 minus 3 is 0 over 0. We got our indeterminate form, which means we have to go about this algebraic technique to simplify. Now, back in Algebra 1 and Algebra 2, I made a big point about radicals in the denominator were bad, right? Recall that? We saw square root of 2 on the bottom. We multiplied top and bottom by the square root of 2 to fix it, because we don't want radicals in the denominator. And if we had a binomial radical, square root of 2 plus 3, we had to multiply by the square root of 2 minus 3 to make that rational thing happen. All right. We're going to do something backwards in calculus where we're going to rationalize the numerator. Here's why. I don't like radicals at the bottom, I still don't. If we end up with an answer with a radical at the bottom, I'm still going to fix it. But the issue with this is not the radical on top, it's the 0 on the bottom. That t on the bottom is my problem. And at this point, there's no way to make t go away. So I'm going to complicate my expression to give myself an opportunity to make t go away. So watch what happens here. I multiply this times the square root of t squared plus 9 plus 3. And using the same technique I would do as if that expression was on the bottom. Okay? So when I multiply this times this by difference of squares, I'm going to get this squared, which is just t squared plus 9, minus this squared, which is going to be minus 9, all over t times the square root of t squared plus 9 plus 3. So again, this is just the difference of squares. I multiply those together, gets rid of the radical to make these two pieces. I multiply these two together, makes that piece. The positive and negative products cancel. The outside and inside products cancel, leaving me with that nice expression. All right, on the bottom, I kept this t right here. Even if multiplied through it, we could do a distributive property there. That's my issue. I want that to go away, so I'm going to keep it segregated from everything else. That t is my problem. I want to keep it away. So don't multiply it through. Just keep it separate on the bottom. All right. Notice on top, we got a plus 9 and a minus 9. They cancel. What's left on top is just t to the second power. Now I've got one thing on top, I've got two factors on the bottom. A single factor with a single factor is legal reduction. So I can cancel that t with that t and make t on top then, right? So that gets me to limit as t approaches 0 of t over the square root of t squared plus 9 plus 3. If I put 0 in now, I'm going to get 0 on top. This is going to be 3 plus 3 on the bottom. 0 divided by 6 equals 0, and there's my answer. Okay. The problems you have in the homework tonight will be of that variety. They're in section 2.3. Okay, there'll be the factoring, there'll be the simplifying, there'll be the fixing radical binomial numerators. All right, so try it out. Again, if all else fails, the chart still works. Let t get really, really, really close to 0 for both ends and see what it's approaching.